guys, so this is the first video. This video we're going to talk about ionic bonding. So without further ado, I am going to share my screen and we'll get started. Okay, so the start of this unit is going to be all about bonding. So there's two types of bonding that we're going to talk about, and the first is called ionic bonding. Now, we've talked about ions, how those are formed, but we haven't talked about how ions are what facilitate bonding. So just as a refresher, ions are going to be any atom or group of atoms that bears one or more positive or negative electrical charge. So if we're seeing an exponent that is positive or negative, then we know that it's going to be an ion and not just its neutral atom. Now, specifically, we can have a cation or an anion, which we've talked about. This is where a positive ion forms when an atom loses one or more valence electron. So the word right there should be lose. In order to attain a noble gas configuration. So remember, all atoms are attempting to make this really stable noble gas configuration. So you have 8 electrons in that valence shell. Now with sodium, the way that it's going to attempt to do that is it's going to lose an electron. So when we are losing an electron, so minus of a minus, you're going to get a plus charge. So that's why sodium would have a plus charge. Now an anion is when a negative ion forms, and it's when an atom gains one more valence electron in order to obtain that noble gas configuration. So our example here is chlorine. So remember, chlorine has 7 valence electrons, so it wants one more to attain that full shell, which it wants so badly. So that's why we're going to gain a negative, which is going to make a negative charge. So the word in that blank should be gains. Now, sometimes we call it charge, but other times we call it our oxidation state. Now, we talk about why it's called an oxidation state probably at the end of this unit or when you enter into AP or college courses. Just know for now that it's interchangeable between charge or oxidation state. Now, there's a trick, as there always is, to determine the oxidation state of a particular element. So what I want you guys to do is on this periodic table, just copy down what I'm going to write in right now. So group 1 will be +1, group 2 is +2. We skip the transition metals because they're super weird. Then we go to group 13, which has +3. This next one, group 14, this can be plus or minus 4. This one really depends, and it can be very specific to elements. Then we have -3 for group 15, -2 for group 16, and -1 for group 17. Now, you might be wondering why we don't have a charge for our noble gases. It's because of that idea that they're already at a stable configuration. Because they're stable, it means that they don't need any electrons, so they don't typically form into ions. Okay, so let's practice. So what this is going to ask us to do is determine what the element symbol is, as well as the oxidation state. So for example, we have sodium. So sodium on the periodic table is in group 1. It's always represented as Na. Now for oxidation state, because we know it's in group 1, we can look and say, okay, we have a +1 charge. Now I want you to try the next one. So pause this video just for a sec and we'll continue on. Okay, so for chlorine, chlorine is located in group 17. Group 17 is represented by the -1. So we have a -1 charge. Chlorine has a symbol of Cl. Okay, and the last one I'm not going to do on here, so you'll need to try that one on your own. So that is it for our ionic bonding notes. So if you have any questions about that, make sure to